Okay. Are you guys ready for 1 hour talk? I try to be quick. So, yeah, who's that guy? Just to be in the spirit of GraphQL, I made this beautiful thing. Yeah, so my name is Nicola. I'm a software engineer here at Commercetools, and you can find me on the internet by the username. And I wanted to start the talk by continuing what Philip already mentioned in the talk before, that we should share more brownfield examples. And I think for us, as we mentioned also before, it's more like the spirit of this meetup, this GraphQL meetup, that we want to share our experiences with the other people, and so we can benefit from each other. And so today I wanted to talk a bit how we've been using and adopted GraphQL at Commercetools. And before I do that, I wanted to start with a little backstory. I don't know if you remember, but back in 2015, there was the first React Europe conference. And there was the first time where Lee Byron announced the GraphQL specification. Did any of you were at that conference? Okay, yeah. Well, it was really exciting. And I was there with my colleague Oleg, which was mentioned already a couple of times. And if you've been at the GraphQL Europe, he was one of the organizers. But the thing that I remember mostly was that the moment the GraphQL specification was released, he started reading it. And he went straight till late at night to really read all the specification and learning. He was so much into it. And I think this was the key moment where later on Sangria was born. Sangria, for those who don't know what it is a Scala GraphQL implementation. It was also mentioned a couple of times at the GraphQL Europe. And I guess in the backend Scala community, it's one of the, it's like a well-known library. And this is what we've been using also at Commercetools. And if you see the date there is like 3 or 4 weeks after the conference, and he already made like a pull request to add basic support of GraphQL to our platform. And yeah, this was like really amazing. And I think this showed also how much like the excitement we had about it and the commitment we had to explore this new technology. And at that time we started we were basically building the MVP of our web application, which is called Merchant Center. And this is what my team and I are working on a daily basis, basically. And the Merchant Center is basically the source of the experiences that we want to share today, because we've been working on that. It's a client application, and as we mentioned already, GraphQL is mostly client-driven, let's say. And so what is briefly this application is a UI application to help the user manage their data in our platform. And this includes, for example, product or category managers, marketing managers, e-commerce managers, whatever. So they use this application regularly to do full order fulfillment and all this kind of stuff. And the application is already quite complex and big, and is powered by React. We try to make it user-friendly, obviously, and we focus mostly on enterprise features. And we know, as front-end JavaScript developers, that building such user interfaces is hard. And this also has been mentioned before, the JavaScript fatigue. What it is, basically, what it means is that in the JavaScript or front-end ecosystem, there are so many new tools, so many new things, new also different ways to do things, that the barrier for people to learn those things is high. And this is what is mentioned as fatigue, basically. And one of those things relates to the data fetching problem. And also this was mentioned also before a couple of times. And in this talk, I'm going to explore a bit how we solve some of those problems. So in this image here, which is made by Lynn Clark, if you know her, she's an engineer. She works at Mozilla, and she does this thing called code cartoons, where she basically explains code and software with cartoons or sketches. So I wanted to take those pictures because it really makes it easy to understand those problems. So on the left side, we have in the middle like a client that wants to render some data, specifically like an avatar picture and some name, location, some information there. And so it asks the server to or one of the APIs to get this data, right? And so the server returns a predefined set of data because it's a REST API with a specific model, and everything is fine. But then, as soon as the client wants to display some more information, we have a problem because we don't have this information available from the REST API. And so this is what is called underfetching, because we're getting the data that we get from the server is not enough, right? We're not getting all the data that we need in the front end. On the other hand, on the right side, we have basically the same example, only that the client just needs one tiny information. But the server still provides the same set of data, right? And this is described as overfetching, because we're getting too much data from the server. And in the examples on the experiences that I'm going to talk about, we're going to see how we solve, let's say, both of those problems. So the first experience basically starts like this. So we have our product owner, product manager that comes in and says, guys, we need to build this new UI feature, which where the user wants to see and explore a category tree, right? And in order for you to understand how, in our case, a category tree is model, I just need to explain shortly how our categories model work. So in our platform, categories are basically just a flat list, and they reference their parents. So what it means is in the first category, you see, doesn't have a parent, and so we consider it as a root category. The second category has a reference to the parent with ID 1, which means it's a subcategory of the first one. So with that in mind, this is what we need to do in order to get the data to render the UI, right? So we need to make a query to fetch the root categories, so all the categories without a parent. And then when we start navigating to, I don't know, category 1, we will fetch all the categories with a parent of ID 1, and so on. And in this case, for example, we're making 3 requests, which, yeah, it's not that bad, but it's also can be better. Then we build this feature, everything is good. After some time then, the PO comes in again and says, guys, you remember the feature you built for the category tree, right? Well, we just need to add 2 little tiny features. And I want to be able to see the number of subcategories and the number of products for each category, right? How hard could it be? Well, this is what we need to do. Because those extra information are not available from the normal API endpoint, we needed to make extra requests in order to get all this information. So if we look at the queries again that we made before, when we're fetching, for example, the root categories, for each category that we get, we need to make 2 extra requests, right? In order for each category to get the number of subcategories and the number of products. And you can see how this quickly blows up. And we're ending up having the so-called n+1 problem, which in this case is double because we need to fetch 2 extra information. And so we tried this just to see what the real problem was, like what was the outcome of this. And we saw that in a project with an average number of categories, we were ending up making over 100 requests, which was like crazy. And so we sat together with the backend, specifically with Oleg, to come up with a solution for that, right? So from an like idea perspective, if this was like the base category model, this is what we were expecting from a client perspective, right? So we wanted to get the categories, and for each category we will also get the child count, the product count, and potentially also for the children the same thing, and so on. And turns out that this was actually not that difficult to implement with GraphQL. So Oleg built it, this new schema in GraphQL, and luckily, basically at the end, we ended up making only 1 request instead of 100, right? So we were able to solve a big problem with a small effort. And this actually was the pull request that Oleg did in order to implement this new schema. And as you can see, it's like 3 lines of code, and half of it are only like tests. So like the real implementation was really, really simple. You may ask, well, we could also build this with REST, right? So one option might be, okay, we build a new endpoint with those extra fields, right? But this obviously has some problems, right? So it increases the maintenance of the backend developers, because if we start adding new endpoints for every new feature that we need, we end up with a huge amount of endpoints, right? And also, we're ending up building those extra endpoints, which might also be public APIs, only for those specific cases, right? Well, the other option might be to add those extra fields to the existing endpoint. But this is also not good, and actually this is like, we shouldn't do this, because we're potentially affecting existing users, consumers of the API, because we are introducing new fields, and if resolving those fields is really expensive, we end up affecting everyone that's using the API, right? And again, the word like having just one use case doesn't justify extending those existing APIs. And if you look at from a GraphQL perspective, it's really easy to extend the schema. Does not affect maintainability because, for example, we still have one endpoint with GraphQL. We're not building new endpoint for every new feature. We just need to extend the schema. And most important, we're not affecting any existing consumers of the API, because if there's a new schema, there are new fields in the GraphQL schema, only whoever is asking for those fields will eventually get, let's say, a performance hit, but whoever was making requests previously without those fields, it wouldn't affect him, right? So this is good. So we were able to extend our existing API without affecting its performance. And like I said, because the way GraphQL works, you can, when you ask for a field, you need to write a resolver usually to get the data in order to return a value for this field. And this allows to specifically optimize those resolvers. Whether, for example, whereas in with the normal REST API, it's hard to do performance on specific fields. You probably have to do performance for the whole API, right? So this is also, and I'm gonna talk a bit more about this later. So the second experience we wanted to share was also something we mentioned in the discussions before. So our merchant center, in order to start, has to do to gather some data, to bootstrap the data in order for the application to be able to be ready to start. And in our cases, those were the API requests that we needed to make. So we need to fetch the user, and then when we got the user, the project of the user, and so on. And in our front end, then we were handling this data, because we're using React. We have this unidirectional data flow, and so we have action creators, and then we get the data, we dispatch an action, and the data is stored somewhere, and so on. And this is really a good system to reason about, but it might get a bit verbose. Like there's a lot of code that you have to write in different places. And in our case, the implementation that we had some problems with it that we wanted to solve. So for example, we didn't normalize the data. More than 50% of the data that we were getting from the API, we weren't using it. Because of all those different requests, we had complicated business logic, and the way then we were handling this to make the application start, there was a lot of logic basically that was at some point hard to follow and understand for new people coming into the project. And this also leads sometimes to critical bugs. And so again, at some point, luckily, the PO comes in again and asks for a different feature. In this case was to show a list of user permissions. The feature here is not important, but it basically relates somehow to the endpoints that we were talking about. And luckily, then we took the chance to tackle this technical debt, this technical refactoring that we wanted to do together with a user story. And this is actually something that our team has been doing to don't work on technical depths alone, but instead to include them in user stories if they bring user value. And so since we had a feature request related to this topic, to this context, we took the chance and worked on the technical refactoring for that. And so we sat down and we wrote down a list of the requirements that we wanted to do to achieve with this refactoring. And one of those was obviously we wanted to reduce the number of network requests that we were making when we were bootstrapping the data. Obviously, we wanted to get only the data that we needed. We wanted to reduce the complexity of the business logic that we had. Additionally, we wanted to have normalized data and also optionally caching. We wanted also to being able to easily extend this model in case we needed different features in the future. And last but not least, we also wanted to get more insights about those requests, those queries. So gathering metrics specifically. And obviously we went with GraphQL for the server and Apollo for the client. We were actually using Apollo already for other things, so it was really natural and easy for us to just use it also for this case. But we were mostly focusing on the GraphQL part. And so if we look at this picture again, what we did basically was we went to the server and we implemented our own GraphQL schema that represented basically the information that we were getting from the API endpoints. And so we developed this first, we implemented this first, and we put it live to production. And basically, at that moment, we had the normal REST API, and next to it, the new GraphQL endpoint. And this is, again, something that also Philip mentioned, to incrementally adopt GraphQL next to your existing APIs, right? And after that, then we went ahead to migrate the front end to use the new endpoint, and eventually we can also get rid of the previously endpoints because we didn't use them again. And so, like I said, we easily incrementally migrated our existing APIs into GraphQL without breaking anything. And if you look at the list of the requirements that we listed before, well, we now are making only one request with GraphQL, right? We only get the data that we ask because the way GraphQL works. We reduce the complexity of the business logic in the front end because using Apollo, we were able to get rid of all this boilerplate code, like with the action creators, with the reducer and everything around it, because all those were handled out of the box by Apollo itself. And additionally, also Apollo does normalization and caching on its own. And again, because of GraphQL, then we are now able to easily extend the schema whenever we need to. And for the last point, we then added a new feature called Apollo Optics. If you haven't heard of it, I think it's been released recently. It's basically a really simple agent, let's say, that analyzes your GraphQL queries and pushes them to let's say, a service. And then, so this is like everything you need to do in order to start using Apollo Optics. So it's really, really easy and simple to do. And this is what you see then in the Apollo Optics UI. So for example, on the bottom, you see the queries and the fields, and how much time does it take for a field to be resolved. And you see then a lot of more information like performance over time, performance distribution, and so on. So it's really easy to just start using it and getting insights about your queries. And for us, one of the next steps we want to take is to analyze those queries and to start optimizing wherever we need to. For example, here you see on the right side the slow queries, and on the left side the fast queries. And you see that we do have some slow queries, but it's not that bad. So most of the queries are around between like 100 and 300 milliseconds, I would say, which is not that bad, but we can also improve it. And this really will help us achieve that. And as I mentioned before, with GraphQL, because you're resolving each field individually, you can really then narrow down the optimizations that you do on the field levels. Another way that you can also gather those metrics that I wanted to mention is that with Sangria, for example, so the Scala GraphQL library, Oleg implemented a feature recently called slow queries. And how it works is that if you have a query like this and you enable slow queries, you will get a whole bunch of metrics related to specific fields, basically. And so once you have those metrics, it's just a matter of pushing them to one of your services, like Grafana or InfluxDB or something, where you can then build some dashboard or something where you can display those metrics. So this is also like another way of easily getting metrics about your queries. So to conclude, from our experiences, basically we saw that it's really easy to incrementally adopt GraphQL next to your existing APIs, and also to adopt tools like Apollo and Relay next to your code base. And by using those and replacing the functionalities step by step, you can really get rid of a lot of boilerplate code and complexity. And yeah, for us it was really good to see how easy it was to solve a big problem to extend existing functionalities with small effort. And as I mentioned also with the metrics, doing optimizations on specific fields will allow you to tackle those performance problems, because they don't affect the entire API. They might just be co-located to specific resolvers. Yeah. Thank you. Do you have questions?